Hello, myself SM Ali from SM Techno Engineering and Software Services Private Limited. I am a mechanical engineer, M.Tech in HVAC, and I have been a professional trainer of over 12 years. Today I am here to record a brief demo on Revit M.E.P. So before starting Revit, let me explain about BIM, because Revit M.E.P. is a software from Autodesk work on BIM concept. So it is required to learn about BIM before starting Revit. So what is BIM? So in order to understand what is BIM, let me play a small video clip to get the idea about the BIM. So anyhow, BIM is Building Information Modeling. Just have a look.
What is BIM? BIM is very much talked about in the building industry, but what is it really? What is it used for, and who should use it? Some say BIM is a type of software. Some say BIM is the 3D model of buildings. Others say BIM is a process, or that BIM is nothing more than an organized collection of all building data. BIM is all of the above and more. Now let's see BIM explained in layman's terms. When it comes to BIM, everything begins with a 3D digital building model. This model, however, is more than just simple geometry and some interesting textures added to it for visualization.
So here in BIM concept, we are dealing with a single database, and in BIM concept, before dealing with actual, first we'll do in a virtual way. So in BIM concept, we are dealing with the 3D intelligent building and with the 3D intelligent components for the services. And before dealing in actual practice, if you complete the work in a virtual way, so the problem which is going to happen on site can be rectified at the time of design stage, and we can save a lot of time on site and material.
The BIM model consists of the virtual equivalents of the actual building sections used to create a building. These intelligent elements are the digital prototype of the physical building elements such as walls, columns, windows, doors, stairs, etc. that allow us to simulate the building and understand its behavior before the actual construction begins. Now let's see what a BIM model can be useful for. 3D.
So the first option in BIM is 3D visualization. It means if you are dealing with the BIM concept, means we are working with a 3D intelligent component. Not just 3D component, we are dealing with a 3D intelligent component, and that intelligent component can link with the other component at the time of design.
Visualization. Of course, the most basic use of a BIM model is for creating realistic visualizations of the planned building. Your BIM model helps your design decisions by comparing various design alternatives and for selling your design to your client, the local community, and other stakeholders as well. Change management.
Next concept in BIM is change management. In BIM, we can say change anywhere will update everywhere. For example, if you are using CAD software, in CAD software we are dealing with the different types of drawing, and if you do any changes in plan, will not automatically update in section. But in case we are dealing with when we are dealing with the BIM concept, for example using Revit M.E.P, because Revit work on BIM concept. So if we change anything in the plan, automatically it will update in all other views like section, elevation, etc. Why? Because we are working with the 3D intelligent component, not drawings like AutoCAD.
Since data is stored in a central place in a BIM model, any modifications to the building design will be automatically replicated in each view, such as floor plans, sections, and elevations. This not only helps in creating the documentation faster, but also provides stringent quality assurance by automatic coordination of the different views.
The next option in BIM is building simulation. So now we are talking about saving of energy, green building, etc. So in BIM concept, we are also dealing with the building simulation.
Simulation. BIM models contain more than just architectural data. Information about the different engineering disciplines, sustainability information, and other characteristics can be easily simulated well in advance of actual construction. Data management.
So the next option is data management, and this option also very useful in BIM concept and followed by Revit. For example, if you are dealing with a metal takeoff using CAD layout, so manually we are going to read the drawing, we are extracting the number of diffusers, number of light fixtures, etc. But in case if we are dealing with the BIM, for example using Revit software, in Revit, when we use any component in the project, you will find the entry in the database. And Revit work on BIM, and BIM offers single database, and when you are using any component, you will find the entry in the data, and that information can be extracted in the form of a schedule like Excel program with 100% accuracy at the time of metal requirement or metal takeoff. So this also one very excellent option offered by BIM and followed by Revit.
BIM contains information that is not visually represented at all. Scheduling information, for example, clarifies the necessary manpower, coordination, and anything that might affect the outcome of the project schedule. Cost is also a part of BIM that allows us to see what the budget or estimated cost of a project might be at any given point in time during the project. Needless to say, the data put in a BIM model is not only useful during the design and construction phase of a building project, but can be used throughout the entire building life cycle, helping to reduce the operation and management costs.
So if you talk about BIM, so BIM is the concept not just for design. BIM is a concept right from the design till the demolish of the project, including the maintenance project, project maintenance, etc. So we can consider BIM is a concept for the complete life cycle of the project, including the services. So remember, BIM is not a software. BIM is a concept, or we can say BIM is a concept for the complete life cycle of the project, right from the design stage till the demolish of the project, including services. And Revit is a software from Autodesk, work on BIM concept for designing, for drawing, for metal takeoff, for modeling, etc. So after learning the concept of BIM, now we are ready to discuss about Revit. So as I said at the beginning, Revit is a software from Autodesk, and you all know about Autodesk. AutoCAD is from Autodesk, 3 Max, so list of software. So this Revit M.E.P software also from Autodesk and work on the BIM concept. So here the advantages of Revit: lessened field cycle time, next better organization and collaboration between the services and architectural and structural, small turn time ratio, minimize of waste at the time of working, because at the time of design stage only the issues which is going to happen on site can minimize at the time of design stage. So you can expect saving of time and the material on site. Next, increased on site renewable opportunities. Next, greater error detection and risk mitigation, and of course improve employee productivity. Next we'll talk about the special features offered by Revit M.E.P software. So the key features for Revit M.E.P software. The first option is coordination between M.E.P services. Not only M.E.P services, Revit offer coordination between the architectural, M.E.P services and structural. But here we are talking about M.E.P services, so we'll talk about the services. So between the services you'll find the coordination, or for example if any change in the architectural design at the time of design stage, So as per the requirement, one can change in the services or vice versa. Next, operation of software is parametric. It means change anywhere will update everywhere. For example, if you talk about the equation Q equal to AV, keeping the Q constant, say flow rate in ducting. If you keep the flow rate constant in duct, and with that if you increase the velocity, automatically the duct sizes will reduce. So it means Revit work on parametric engine. So if you change one parameter, automatically as per the relation to other parameters, the values will update. And this option also very useful for designing. Next, Revit supports the design. So in Revit we can deal with the designing, means calculation part. We can deal with the drawing, and very easy and with very less time compared with AutoCAD. And of course we can go for schedule required for the building project for metal takeoff. So the next option, load calculation and energy analysis, and in very advanced way with the less effort. Next, duct and pipe designing. So we don't require a separate duct sizer or pipe sizer in Revit, because Revit offer tools for ducting and pipe sizing as per the required methods. So you can expect the different methods for duct sizing, like equal friction method or static rigging method or velocity method. Even for piping also you can go for the velocity method or the combined velocity plus friction, etc. So no additional duct sizer or pipe size is required. You can use the inbuilt option within the software. Next, one more very useful feature, auto layout of ducting and piping. So for this I'll show you an example directly in the software. So here, this is also one excellent option in Revit. So for example, after completing the logical connection, because in Revit first logical connection is required before dealing with the physical connection, and this auto routing option will help to get the different possible routes for ducting as well as for piping. So for example, when I click this diffuser here, I'm going to use the tool called generate layout, and this option will appear only after completing the logical connection. So already I complete logical connection for this area, just to show the option for auto routing. So click this diffuser, and when you go for this generate layout, here we'll go for some settings, say 3500 the offset for the duct, same here, and we'll also select the type of the duct. For example, I'm using rectangle duct tabs, and even for branch also the same option. And after this, here we can go for the different option. You see 1 of 6 solution. So 1 of 6 is straight and turn with the branches, and the second option in this way. So like this, which is best as per the site condition or as per your experience, we can click finish to convert this into duct. So this also very useful option to save lot of time to get the auto routing for the ducting and auto routing for the piping. Next option, logical and physical system. So in Revit, first we'll create the logical connection, then physical connection. For example, we'll create the logical connection between the light fixtures and lighting panel, and then only you can deal with the wiring, and the load will update in the panel. In the same way, for mechanical service, we'll create the logical connection between the diffusers and AHU, then we'll deal with the ducting, then only the duct sizing can be done. Next, index route analysis, and this is also very useful tool, especially to select the fan and the pump. So most of the engineers at the time of selecting the fan and pump, the route, index route, especially for big project, finding the index route sometimes it's very time consuming and a lot of confusion. But in Revit, after placing the equipments and physical connection, easily with the tool called system inspector, we can find out the index route, so that we can find out the total pressure drop to select the fan and to select the pump. Next, we have walkthrough and fly through for client presentation. So here I attach one example. So here you can have a look. So this is example for a walkthrough for client presentation. This is like a real system, but this can be prepared with a very less effort in Revit. After completing all this equipment, we have a tool called walkthrough, and using that walkthrough tool you can create the animation like this for client presentation. Next, all 3D views, 3D modeling. So in Revit we are working with the 3D intelligent component. We are dealing with all modeling, and no doubt we can go for the drawing also, but Revit means basically we are dealing with the modeling of the component, like piping modeling, ducting modeling, and different other components modeling for M.E.P site. And if you talk about architectural side also, we are dealing with the 3D intelligent building. And as a mechanical or electrical engineer, when we start our service, we are going to link a 3D intelligent building which is prepared in Revit architecture. Next, creation or creating section views in second. So here I'll show you one example. So for example, after completing this ducting, if I want to create a section for this area, simply we'll create a slice by using the section tool, and you'll get the section. So this is very easy. So here I'm going to click on this view tab, and from this create panel I'm using the tool section, and simply I'm going to create the slice like this. And when you do this, automatically the software will create the section for this area. But how to access? Simply double click this, you can able to access, and now it is in single line view because of the settings. For example, if I click this fine, you can have a look with the 3D view also. So, and later if I add or remove anything in this area, automatically the section also get updated. For example, if I select this equipment, if I delete from this, it will delete from the section also. Or else if I select this duct and if I delete from the section, it will delete from the plan view. So in Revit we are working with the multiple views of the same component. So we are dealing with the modeling, we are not working with the drawings. Next, plumbing and firefighting design can be done. Lighting load, power load calculation for electrical side, and finally detailing documentation, annotation for the shop drawing. And no doubt at the end we can also create the families, means modeling components, like creating the fittings for pipe, creating the fittings for ducting, and if any new component is required which is not available in the software, and that can be created in a separate family editor, and that we can call families. So families refers to 3D intelligent component, that component what we are going to use in the project. Okay, so next we'll talk about the training details. Here the prerequisite for to attend this program is you should have the basic knowledge of M.E.P design and the system configuration to run this software, whether you are using a PC or a laptop. So the recommended processor is i3 or above, and the RAM 4 GB minimum and 8 GB is recommended. And if you have minimum 5 GB hard disk space, you can able to install the software. And I recommend to use Windows 7 64-bit because 32-bit is not applicable, because in the latest version now, if you talk about 2018 version, 32-bit is not applicable. You should have a minimum 64-bit operating software. Next we'll talk about the syllabus. So if you talk about the Revit M.E.P syllabus, we are offering with project, because learning Revit with project is important, because many options will activate only in sequence at the time in between the project when it is required. Means many options will not available. If you search also, it's not available. It will activate only in at the time of requirement and as per the sequence, as per the project requirement. So learning Revit with project is must, and we are offering this training with the project in metric as well as in English system. So the training will end with the project in both the system, and will also offer the data, material, and lot of stuff. So we'll talk about the syllabus. So the module 1 Actually, this course is divided into 4 modules. Module 1 is HVAC, and module 2 is electrical, and in module 3 we'll talk about plumbing and firefighting, and module 4 is common for all the services, which includes detailing, documentation, families, etc. So if you talk about module 1, here we'll start with the introduction, then we'll learn how to deal with the training file setup. Next we'll talk about modifying the views, then common tasks in chapter 1. In chapter 2 we'll talk about the project, so the project setting, how to link the architectural building from the architect to start any service, then view template including the VG, visibility graphics. We'll go for different settings for different services for visibility to avoid confusion. Next, in chapter 3 we'll talk about modifying system settings, which is again common for all the services, and system settings refers to the software settings. So like here, general system options, file location, spelling, snap, etc. Next, in chapter 4 we'll talk about planning mechanical systems, so we'll start HVAC module from chapter 4. Chapter 1, 2 and 3 is common for all the services. So in planning mechanical system we'll learn preparing spaces, the first step in designing for load calculation, and after learning preparing spaces we have different cases for spaces. Then we'll talk about zoning, and after completing the zoning we'll learn about analytical model, means load calculation setting. Then we'll talk about heating and cooling loads, and heating and cooling load is very easy in Revit, because all the external sources will automatically analyze by the software, because we are working with the 3D intelligent building. Next we'll talk about the zone color scheme for presentation and airflow schedule. Then chapter 5. In chapter 5 we'll talk about mechanical air system. So chapter 4 is for load calculation, and chapter 5 is for air system, like placing the AHU, diffusers, hosted air terminals, non-hosted air terminals, etc., duct designing, etc. Here ductwork, manual creating ductwork, auto routing, etc. Next, in chapter 6 we'll talk about the piping system, adding mechanical equipments, then creating piping system, nothing but logical connection, then adding pipe using auto layout as well as using manual layout like ducting, then adding valves, then pipe sizing with the different methods, then finally inspecting the system to get the result, and with the inspecting system you'll also get the critical path index route for pump selection. Next, we can also check the system with the different tools. Next, in module 2 we'll talk about electrical. In electrical, first we'll go for lighting load, then power load, but before this we'll go with the basic settings like specifying electrical system, defining required lightings. Next, color fill and schedule for presentation again. Next, designing electrical systems, lighting fixtures, adding the light fixtures, IES engineering, eliminating the society data. Next, adding switches, junction box and receptacles, means sockets, power sockets. Lighting circuit with wire, lighting circuit means again we'll create the logical connection. Then creating switching system, then power loads, balancing wire size and breaker services, panel schedule, and at the end we'll also learn how to check your design. Next, in module 3, that is plumbing and firefighting. First we'll talk about the plumbing drainage system, then plumbing water system, then we'll talk about the firefighting sprinkler system. So all these topics we'll cover in detail with the project in metric as well as in English system. So here you can have a look about this main topics and subtopics. And here, designing fire protection system, adding sprinklers, creating piping system means logical connection, then fire protection wet system, vertical supplying pipe to connect the hose reel, etc. Next, module 4, which is common for all the services, that includes detailing, documentation, annotation, dimension and families, which is common for all the services. So in this, creating documentation views, which is important to get before starting the shop drawing, duplicating plan views, creating dependent views. If you are dealing with a big project, then dependent views will help to make a section of that particular view to set in 1:100 scale. Next, creating plumbing isometric risers, creating callout views, which is common for different services. Next, annotations and dimensions, which is also required for all the services. Next, detailing, model based riser diagram for electrical, then creating wiring, model based isometric for ducting, including ducting, then detailed drafting components. So in Revit we have a separate view even for drafting also, and at the time of modeling, and when you change the view, the plan view, you'll get the plan view, but if you want, you can go for only drawings. For that we have a separate drafting view. Next, if you already have the completed drawings in CAD, we can also import from CAD. So this is not the end. So here we'll talk about Revit M.E.P families, which is also a very important topic. So working with the 3D intelligent component like modeling, like solid modeling, like Pro-E, CATIA, ANSYS, etc. So in Revit also we are dealing with the modeling of the different component, and that component can be used at the time of project for different services. So fan families, then VV box, electrical equipment families, then toilet families, means plumbing fixture families, flange families, etc. And we'll also talk about this additional topic which is recently updated, and this also very important for interview point of view, as well as if you're working in as a design engineering consultant with Revit. So CAD to Revit, how to convert the CAD file into Revit, how to import and export, and how to deal with the tracing. Next, work share and work sets for the central file, because in Revit we are dealing with a single database, and you know this Revit work on the BIM concept. So this will help you to get the central file, and with the help of central file, the different discipline can work with a single file with a single database. Next, we'll go for interference check for clash detection. Next, creating central file, and again this point is related to point 2, work share and work set. Next, creating sheets to take the print to start work on site, then walkthrough for client presentation. Next, metal takeoff, nothing but the scheduling for different services, metal schedule. Next, cable tray, creating conduits, then low current logical and physical connection. Then auto spaces, this was a new option in 2017, and in 18 we have some more updation. Next, duct pressure loss report, pipe pressure loss report, and duct thermal and acoustic lining. So we'll also talk about this additional topic. Next, course highlights. We are offering classroom training if you are in India or in Hyderabad, and you can also join in live online anywhere from the world. And we are offering this live online from 2009 onwards, and it's a live online, it's not recorded. And we also offer the video mode training. So those who don't have time or want to complete in crash, so they can also join in the video mode. Next, BIM concept, as we discussed. Project included all the services. So M.E.P means we are dealing with all 4 services, and the faculty, myself, having a Gulf experience, and from last 12 years I'm in a training field. Before that I work as a design engineer, and I also work on site for some time. Next, we'll provide you detailed step-by-step notes which will help you at the time of practice when you involve in the project. Next, basic to advanced level. This course is for beginners as well as for the experienced people, those who are already working in design for M.E.P side. Next, concept based training. Software latest version, we are dealing with the latest version 2, which is required at the time of interview also. Next, training includes designing, drafting and estimation, and will also help online assistance after completing the training. And if you are learning in a classroom, the classroom is completely digital classroom. So for more details, you can visit to our website, that is www.smtmep.com, or you can also call on or WhatsApp on this number. 91 is the India code and 9848699535, or else you can also email to get the information. And as I said, we are offering the mode of training in classroom, live, online as well as in video. So hope you like this video. So please comment, like and share. Thank you.